Hey everyone, welcome to this video on cybersecurity interview questions part 2. Here you will have an overview of various software and programming questions that can be asked when you apply for a job in the cybersecurity domain. Our experienced instructor Bipin will take you through these questions. So let's get started. But before we begin, make sure to subscribe to our YouTube channel and hit the bell icon to never miss an update from Simplilearn.
First question being, how do you keep a computer secure? Now, this is going to be a very generic question, so you want to put your best foot forward and you want to identify the most common methodologies on how you can keep a computer secure. So when we talk about computers, the first thing that you want to talk about is authentication mechanisms, where you want multi-factor authentication or two-way authentication to ensure that your accounts are kept secured. Now, if you look at using passwords, depending on how passwords are being stored by the application, password attacks can be possible, either a brute force attack or a dictionary-based attack, or even password guessing attacks are possible. To mitigate those kind of attacks, we need multi-factor authentication to ensure that accounts are kept secure. Now, even if we are using multi-factor authentication, we also want to look at secure passwords, which means that the password is complex enough to withstand most of the common attacks, and a brute force attack or a dictionary attack is just not possible. So we want to randomize our passwords. We want to create a complexity where a password meets standards such as has at least one lowercase, one uppercase character, has numerics and special characters, and is randomized, is not based on a dictionary word, doesn't contain usernames, email addresses, phone numbers, or anything that is personal to that particular user. Third, keep regular updates, which means that there will be patches that will be released for the application, for the software that you're utilizing. Download the patches, install them on a regular basis to ensure that you are secured against the most recent attacks that have been identified. Install a good antivirus. Could be an internet security suite, which will have an antivirus, intrusion detection system, a firewall, and will help you protect yourself against ransomwares, malwares, and any script-based attacks. Also have a specialized firewall on your system. Could be a host-based firewall or a network-based firewall to ensure that attacks are kept at a minimum, and you have your network definitions in place to allow or disallow connections from happening to your devices. Have anti-phishing softwares installed as well to ensure that you are not getting any spam mails. Even if you do, you're able to identify that and not fall prey or victim to those spam mails. Phishing attacks are generic, where they are directed towards individuals and they prey on the gullibility of that particular individual. So our Nigerian frauds or the lotteries that we win on a regular basis of hundreds of $1 million, those messages, the emails that we receive, they are all phishing emails where they're basically prone to victimize the user and then rob them of money or install some malware or do some other malicious activity. If you want to enhance encryption about data that you have stored on your devices or on your or that is accessed by your software or being transmitted by your software, use encryption. Encrypt your data, whether it is at rest, whether it is in motion, or whether it is at use, thus reducing data leakage and data loss possibilities. And finally, and the foremost, secure your DNS. DNS is the domain name server, which is utilized by computers to resolve domain names to IP addresses. If a DNS poisoning attack is possible, where your DNS settings have been modified by an attacker and you're redirected to a malicious DNS server, that server is going to redirect you to another malicious application which may have a malware or a malicious software as a payload. Also, you don't want people to know your DNS servers and the queries that you're making, so you want to use secure DNS or DNS over HTTPS to encrypt your DNS queries as well. So, in a nutshell, if you follow these 8 steps, your devices, your computers, your applications are going to be as secure as possible. The next question, discuss security related aspects between C, C++, and Java. Now, this is an open-ended question. It depends on which level you're giving an interview on, but we're looking at it from a fresher's perspective. or a less experienced perspective. And thus, these are some of the aspects that we want to look at and the comparisons between C, C++, and Java. So the 5 aspects that we are looking at are pointers, code translations, storage allocation, inheritance, and overall security based on C, C++, and Java. So when we say pointers, we are looking at how we are going to, we are using pointers and stacks and heaps to point to functions, and how we exit those functions, and how those functions are then recalled into the next function. So C supports pointers, it is most secure. C++ also supports pointers, but it is a little bit less secure than C. Java, it is not supported. Direct access is given to memory allocation, and thus it is the least secure as far as pointers are concerned. When we look at code translations, C is able to compile, but it is not secure. Same with C, C++. But in Java, it is an interpreted language, and it is abstracted and secured. In storage allocation, in C, we use malloc and calloc memory allocation, which is less secure because it does not have internal checks on verifying what memory is allocated and the user input that is being compiled or that is being input to that memory, right? Thus, this can allow buffer overflow errors to creep in because of the non-verification of the input data. So it is the least secure. In C, C++, it uses new and delete options and is comparatively secure, but Java uses a garbage collector and thus is the most secure as far as storage allocation is concerned. When we talk about inheritance, the most secure is C, C++. C has no inheritance, so it's not secure. In C++, it is supported, thus it is the most secure. Whereas in Java, there is multi-inheritance that is not supported and thus is comparatively secure. Overall, the most secure out of all these based on these 5 aspects is Java. The least secure is C, and the mid-level is C++. Moving on to question 13. What are the different sources of malware? Now, malware stands for malicious software, right? Malware is basically a software that poses as a legitimate software but has a payload of a Trojan, virus, spyware, keylogger, or some malicious software that is going to have a negative impact on security of your particular device. So the question here is, what are the different sources of malware? We want to identify the most common sources through which malwares infect end user devices in today's world. And we can start with pop-up ads. So most of the websites, if you're visiting untrusted sites, if you're being redirected to sites that you don't know about, there will be a lot of pop-ups coming your way where it says you're the 1 millionth visitor to this site. Please click here to download your gift. Or it will say, congratulations on winning a particular product for visiting this page, and so on and so forth. There are some instances where you can see a banner which is flashing at you on top of the page and says that there are 8 infections that have been identified on your computer. Click here to download an antivirus to clean the infections. So all of these pop-ups are there as a social engineering attack, as a phishing attack, to make gullible people click on those links and download those malwares. Now, the software that is posing as a security software itself can be a malicious software which is going to install a Trojan or a virus or a bot on your machine, compromising the security of that machine. The second is removable media, USBs. And humans have a fascination with USBs. So if you find a USB lying around, it's a free USB, you get excited about it, and you want to take it home, you want to plug it into a machine and see what's on the USB. Worst case scenario, you format it and you got a free USB to utilize. Higher the capacity, the better. But that is one of the most easiest way people use malwares to be deployed on unsuspecting users. If there is a USB lying around, why would somebody want to forget a USB? It's most likely planted over there as a social engineering attack so that a gullible person is going to pick it up, plug it into their device. If the device is not secured enough, it is going to install the malware, right? Then documents and executable files. This is where your viruses and all those creeps in. So let's say you're surfing on the internet, you're looking for a software, and you find the software on a particular website. You do not verify the trustworthiness of that site, and you just download and install that software. Now that software could be malware as well. Thus, if you're surfing on the internet, you're downloading files from different locations, you have to research the website, you have to research the source to ensure that it is trustworthy, and only then are you going to download and execute those files. Thus, internet downloads as well. And when we say internet downloads, it's not just untrustworthy sites. We go to torrents, we go to the dark web or the deep web, and we are searching for other softwares, especially those who are researching security, right? We are always on the lookout of new softwares, and we are always on those forums which may not be so much trustworthy, and we just download those files and start installing them. That is a very bad scenario, right? So you have to be very careful what you're downloading from the internet. Your antiviruses, your anti-phishing mechanisms, your threat intelligence mechanisms, have those mechanisms installed, and you want to verify where your downloads are coming from. Then your network connections. If it is a P2P connection, it is a local area network connection or a metropolitan area network, you have to verify which devices are connected to your machines, and you have to validate those connections before you want to trust those devices and before you connect to them. If you're on a public Wi-Fi, you probably don't want to connect to a public Wi-Fi in the first place. Then comes email attachments. There are so many attachments that come across in today's world, most of them in a zip format or a RAR format. Some of them come as document files where there are macros hidden within them. Macros are scripts that are recognized by Microsoft Office files, right? And then finally, there are these malicious advertisements that we find online, right? Let it be Facebook, let it be WhatsApp, let it be any social media platform that you go, or even your search engines. Their job is to display ads. Their job is not to verify whether the ad is legit or not. It is for us as consumers to be careful and validate that ad and verify whether it is a genuine ad or not. So just don't start clicking on any of the ad, trusting the platform that you're on. Be sure that you are investigating that ad. So these are the most common sources of malware, and the end user will always get infected by one of these mechanisms. Moving on to question 14. How does email work? Now, this is a very, can be a complex question, but we have to keep it as simple as possible. And we have to identify that there are two servers, both of them either using SMTP, which is the simple message transfer protocol, where in this scenario, John wants to send an email. Thus, they've got an email client installed on their machine, which is connected to the mail exchange server, which has a DNS server which maps the routing and which maps the exchange server and inboxes. So when John composes that message and clicks on send, John should be connected to a mail exchange server where the email is sent through that particular person's inbox. So John's inbox will then be validated, and that email will then be sent through the DNS server through the internet and will be received by the recipient mail server. So at this point in time, John also requires the recipient's email address. So in this case, this is Jack. So jack@something.com would be the email address. So while John is composing, the to field will have Jack's email address. The from field will have John's email address. The subject field will have whatever they want to convey as a message. The message body will have the message itself. And then when John clicks on send, it will go to their exchange server. The exchange server will then validate the inbox and identify where that inbox is located for Jack. And then through the internet, it will be sent to the mail server of Jack. The mail server will then identify the proper inbox that email needs to be sent to, and it will store that email in that particular inbox. When Jack opens their computer and accesses their inbox, this email from John will be already waiting for them, and they can respond to it the same way John had sent that email.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Moving on to question 15. What are the types of threats a company can face? Right? And this is where your threat modeling comes into the picture. So you're looking at softwares, you're looking at operating systems, and the company comes and asks you, what are the threats that are most likely that a company will face. So on a broader scale, the threats that a company will always face would be classified as natural threats, man-made threats, technical threats, and a supply system threat. So a natural threat would be an act of God which is outside the control of human beings. Could be storms or any natural occurrences like volcanoes, thunderstorms, flooding, earthquakes, fire, and so on and so forth. So anything that is natural. So it depends on the geographic location that you're in and what kind of climate that area faces, and you need to identify the immediate threats and prepare for them. So if it is flooding that you're looking at, and you want to look at an office, and the possibility of the office getting flooded is real, you probably want to take office at a higher floor so that the threat of flooding is minimized. For fire, we always have a fire drill where we practice our fire mechanism so that we can evacuate all humans as soon as possible and then worry about the technicalities of it. Under any circumstances, under any threats, humans will always have the first priority and then everything else comes in. Man-made threats are where man themselves are a problem. So strikes, lockouts, hackers, theft, war, rioting, all of those are man-made threats, which we ourselves cannot be in control of, but we need to plan for them and we need to have a business continuity plan or a disaster recovery plan for any of these threats that have been identified. Then come the technical threats. Technical could be software bugs, operating system bugs, application bugs that come with the applications that we have, or a hardware failure where a server crashes, a hard disk crashes, maybe the processor stops working, the motherboard stops working, RAM gets corrupted, any of the technical aspects stop functioning, thus creating a break in the business can come under technical, right? So anything to do with computers, let's say a server failing or a patch that is not installed on a particular software, those would come under technical threats. And then the supply system. The supply system are your environmental threats which depend on your supply chain failures. What is the supply chain? For an office to function, there are a lot of dependencies that an office goes through, right? There are a lot of other vendors that support and provide critical infrastructure, non-critical infrastructure for the office to function. For first and foremost, electricity. Without electricity, nothing is going to be powered on and you're not going to be able to function. So if there is an electricity service provider and if there is an electric outage, that comes under supply system. So that's a supply chain failure where the vendor that provides electricity to you has failed in providing that particular service, and now you need a business continuity or a disaster recovery plan. So you probably have an inverter or you already have a power generator plant that is going to generate your own power and supply it to your system, right? There could be short circuits because of fluctuation in the electricity. Maybe the internet service provider fails and your internet crashes, so you have a backup line for the internet from a different vendor, right? And so on and so forth. Maybe your hardware vendors who are supplying you servers, desktops, laptops and whatnot, they fail because they are facing a strike or they go bankrupt, and suddenly you can no longer purchase hardware from your vendor because they no longer are in business. So that's a supply chain failure. So any of these systems failing would also come under threats. So under a broad category, these are the first 4 threats that you need to identify, and then you can elaborate by providing more scenarios based on the experiences that you have had towards each and every of these threats. So a natural threat where you may have had experience where there would have been, let's say, a flooding or any natural disaster which caused a problem for the continuity of your particular business. So identify each and every example for each of these threats and provide that as an example in the interview. What is black box and white box testing? So when you are testing a software or you're testing your infrastructure, there are 2 different tests that you can conduct. The first one is a black box. The second one is a white box. In a black box test, there is no knowledge that is shared with the tester. So let's say you're an ethical hacker and you have been awarded a contract by an organization to test their current application that they have developed. Now, they are not going to give you any information. They're not going to tell you what the application is. They just probably give you an IP address and a port number where the application is hosted. And now you have to fire in your own queries and try to figure out what the application is, try to gather information, see what information can be gathered in the first place. And based on that, you're going to figure out your way, identify vulnerabilities, and see if any of those vulnerabilities can lead to an security incident. So without any knowledge, zero knowledge of the IT infrastructure or the source code, that's a black box attack or a black box test. A white box test, on the other hand, is where full knowledge of the IT infrastructure or the source code is shared. So the ethical hacker has complete knowledge, and based on the knowledge, they are then going to test out the system to see if there are any flaws that they can identify, right? So why would these two audits be important? Because the first one, a black box audit, emulates the attack of a outsider, an external hacker sitting outside the organization trying to figure their way in. Whereas a white box attack can emulate the attack of an insider. So a disgruntled employee within that organization misusing their access controls or their access rights to make unvalidated profits, right? So somebody who's corrupt, who has been bribed, who wants to sell out company secrets so they're going to try to find out vulnerabilities, try to steal data and try to sell it on the gray market, right? So a white box would emulate an internal attack, a black box would emulate an external attack. Moving on to question 17, what is use case testing? Now, use case testing is a functional test and it is also a black box test, right? What is a functional test? It tests the functionality of a particular software once it has been created. Why is it a black box test? Because the user doesn't know what the functionality is. They just want to find out each and every scenario and try to see what that scenario generates as a response. They are not sure whether that is the appropriate response that should be generated or not. They're just trying to find out the response that is going to be generated after they fire off a query. So this technique is used by testers to get the test scenarios to exercise the whole system from start to finish. So let's say it's a login mechanism for an application, right? Now, a user at this point in time, the tester, since it's a black box testing, will know that it is a login mechanism. They will not know the details of what logging mechanisms are being utilized. So they wouldn't know whether input validation is done. They wouldn't know whether output encoding is done. They wouldn't know how the CGI calls are being made. They will not know how the queries are handled at the server side and how the database is going to treat that particular query. So they have no idea whether SQL injection attacks are possible and so on and so forth. So for them, with whatever input they are going to try to insert for that login mechanism, that's a functional black box test. The functionality being whether the login mechanism works, and based on the type of inputs that they're going to put in, whether it creates an unwarranted output, whether they can bypass the mechanism or they can hack into the system because of some of the flaws that were left behind, right? Another example here is a software made for users to use for documentation. The testers will test all the cases that a user can do. So can the user view a document? Can they add new documents? Can they edit documents? And can they delete documents? So this functionality will depend upon the access controls that have been granted to a particular user. So for this particular user, the tester at this point in time, they would not know whether they're an administrative user or they're a regular user. They'll just try to do all of these and then write the responses saying, I was able to view, I was able to add, I was able to edit, and I was able to delete. Now the result will be then sent to a manager. The manager will look at the results and then based on the actual access controls that were supposed to be there for this particular user, then we'll try to identify whether this is an acceptable case or whether there were any flaws within this case. Moving on to question 18. What is static and dynamic testing? Now this is again in application testing. Static testing is done in an early stage of development lifecycle. Now software development life cycles, there are multiple of those. What are these life cycles? There are different stages in which an application is created and provided to the customer. So your first stage would be determining the scope of the application, determining the hardware requirements for that application, then creating a flow chart for that application, a functional chart for that application, and then maybe start coding. Then an architect comes in, tests the code, verifies the code. Then the testing phase comes in, then the security testing phase comes in, and then the user acceptance testing comes in. But In every stage, at the very earliest of all stage, a static test will always be started to see whatever code has been developed, whatever scope has been developed, whether that scope is going to be correct or not. This will include walkthroughs and code review. What is a walkthrough? A walkthrough is going through documents that have been generated and trying to find faults in the documented journey that has been created so far. So let's say somebody has created a workflow or a flow chart for a program, how the functions are going to be called and how they're going to be executed. So a walkthrough would be where all these responsible people will walk through that particular flow chart and find out any flaws within that and then rectify them. If there is any code that has already been written, this code will be reviewed manually and any flaws within that code would then be identified. Static testing will always be 100% accurate in a very short amount of time because it is immediate. You have created it and then the expert is going to test it to see whether everything is fine or not. Right? It is all about prevention mechanism. So since you're doing it at the inception itself, if you find any flaw, it gets immediately repaired. So this is about preventing vulnerabilities from creeping into that application at a later point in time. Whereas dynamic on the other side is done at the end of the development lifecycle. So you have generated the application, everything is ready. Now you want to do dynamic testing. Includes functional and non-functional testing. Functional testing is where the application itself is being tested, the functions to see that all the parameters that are given to the application are functioning properly. Non-functional testing would be where security parameters, administrative parameters, all of them are being verified, right? This is where your test case scenarios come in and you're going to test each and every scenario by generating inputs and analyzing the output that the application is going to give you. Dynamic testing is all about cure. So here you're going to identify vulnerabilities, report them to the management, and the management is then going to figure out a way of patching those vulnerabilities so that they can be mitigated. Moving on to the next question, what are the test levels in software testing? So as far as software testing is concerned, there are 4 test levels: module testing, integration testing, system testing, and the final one is acceptance testing. So in the testing phase of your development lifecycle, the first thing is a module test. You're going to check your routines, your subroutines, your subprograms, procedures that have been written in a program. So all your functions, all your mechanisms for that application are going to be tested. When you go into integration testing, the software may have been integrated with multiple softwares. There may be different API calls coming in, maybe a third-party software on which you're depending upon to supply for information. So all of these integration of various softwares, various APIs are tested to ensure that they are functioning properly and there are no flaws, errors, or mistakes left behind in the integration of all of these softwares. Then the system testing is where the entire system, so including the hardware, including the software, right? It starts from the installation. So now the software is complete. We know which hardware we are going to support for it. We start by installing the software and see whether the installation is going to be completed properly, if there are any errors in the installation process itself. Then once it is installed, the performance of that particular application, the write speeds, the read speeds on the hard disk, the transaction speeds that the application is capable of, the network dependencies that the application may have, all of those would come under system testing. And then the acceptance testing, which is basically a quality assurance exercise that the application meets the client's requirements. So the client in the first stage would have given the scope of what needs to be achieved. In the acceptance testing, you're verifying that that scope has been met and the client requirements have been met, and you can assure the client about the functionality and the performance of that particular application. Coming to the last question in this software programs, what are the valuable steps to resolve issues while testing? So in the previous scenarios when we have started testing, now if you find out, when you execute a particular use case and then you find out a flaw, what would be the steps that you would utilize to address those particular flaws in those tests? The first step will always be record, then you're going to report it, and then you're going to introduce a control process for it. So when you say record, you're going to create logs and you're going to try to resolve all the problems that have happened. Now, when you say resolve, you're not going to recode the application, but you're going to test the system again and again to ensure that whatever is being recorded is accurate and all the logs, all the error mechanisms, all the dumps, all of those that have been generated due to this particular log or due to this particular error are being captured so that they can be reported to the higher level managers. So the next step is once you have accumulated all these logs and records, you're going to report them to the higher level managers, who are then going to investigate it and go back to the developers trying to figure out the best way to mitigate those particular flaws. So the report writing needs also needs to be accurate. It needs to be to the point. It needs to detail what the problem was. It will document all the steps that you took, all the inputs that you put in, and it will also record all the errors, and it will also record all the mechanisms that were utilized and the errors that were generated. And that report will be given to the higher level managers, who can then forward it to the developers, who based on those reports can start their troubleshooting. And then the control mechanism comes in. You're going to define the issue management process. So this process needs to work in a particular manner, where you're doing a test, you're recording whatever is happening, you're creating a report out of it, you're sending it to the management. The management will then take those reports, study them, take it to the developers. The developers will test based on their criteria. They might interact with the testers at that point in time to identify particular flaws, and then they might want to recode that application or develop a patch which, once installed, will mitigate that particular flaw, and then it can come back to the testing phase again, where you can repeat those tests and validate that the flaw is no longer existing. So these are the 3 steps that would be utilized for testing purposes.
And with that, we have come to the end of the Cybersecurity Interview Questions Part 2 on software and programming. I hope it was informative and interesting. If you have any questions related to the topics that were covered in this video, please ask away in the comment section below. Our team will help you solve your queries. Tune in to Simplilearn to watch out for more cybersecurity interview questions. Thanks for watching, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.